Okay, guys, this is lecture 3 for the error analysis. In the last lecture, we studied about the error propagation formula. Okay, so in this lecture, also, we're gonna study some examples of that which are asked in the recent examinations, the previous years. Okay, so let's see. Here we have a question. So it is consider an experiment in which we count gamma rays emitted by a strong radioactive source. We cannot determine the counting rate instantaneously. No counts will be detected in an infinitesimal time interval, but we can determine the number of counts x detected over a time interval delta t, and this should be represented by the counting rate over that interval. Assume that we recorded 5212 counts in a time interval. The distribution of count in random time follow Poisson probability function. Our estimate of standard deviation is. So, guys, it is we studied that once upon a time when we were try the instantaneous velocity to find the instantaneous velocity. So, most of the time it was not possible. So, at that time we take the average speed, means that was the total distance and the total time. So that's how. But that is now possible to calculate the instantaneous velocity at any instant. But it's not the case here. Here we are talking about a radioactive decay of very strong nuclear particle. Okay, so that was just emitting the radiations and the particles. So we can't measure the infinitesimal in very small time in the very instant. What's the count? So we take the average count. Okay, so that's how we're gonna check. So average count, and this emission gonna follow the Poisson probability function. What is that? What is this? This is actually, it means that if there are n number of counts, then root n will give you the error, in n. Okay, so if the count is given 5212, then sigma will be the root of 5212, that is 72. We should record our result for number of counts x in time interval delta t as sigma x. So if you wanna see x, so it will be written as 5212, that is the original number, and error in x, sigma x is 72. Now the relative error will be sigma x by x. Sigma x equal to root x by x. How? That's because of the Poisson's probability function, and it will give you the 1 upon root x, and we know the value of root x is 72, so it will give you 1.4% or 0.014 relative error. So how it is understood? Just remember this Poisson's probability function. Okay, that is root of number of counts. Well, here pages are randomly arranged, so it is from the back PDF. So let's discuss this also. Simple sums and differences. If the independent variable y is related to a major quantity x1 by the relation, if there is addition a constant in y equal to x1 plus c, then del y by x1 will be 1, and sigma y square will be 1 sigma x square. So c will not add up in the error. So del sigma y square will be equal to sigma x1, or sigma y equal to sigma x1 if there is constant. But in the relative error or relative uncertainty, we can see that it is c will come into picture. Sigma y equal to sigma x y. Uh, well, here it is x. Sigma y equal to sigma x. We know that. That's how sigma x y equal to sigma x y x1 plus c. So there is one more example. In an experiment to count particles emitted by a decaying radioactive source, we measure n1 equal to itne counts in a 15-second time interval at the beginning of experiment, and n2 is 19 counts in a 15-second time interval. Later in the experiment, the events are random and obey Poisson's statistical, so it is following that probability function. So that uncertainties in n1 and n2 are known, root n1 and root n2. Assume that we have made a very careful observation of the background counting rate in absence of radioactive source and obtained a value of b equal to 14.2. Counts with radioactive source and obtained a value of this. Counts with negligible error for some time delta t. Find correct number of counts, uncertainty and relative uncertainty in number of counts in first and the second interval. So what is this background count? So guys, it is just like if there is no radioactive element in the present situation, then the radiation by earth, a natural radiation given by earth or the natural particles, that is written as the background count. So if it is measured very accurately, then B is given as 14.2. Okay. So if you are measuring in 15 seconds that N1 count is 723, then original count will be the subtraction of that background count from the N1. So the correct number of counts in y1 is n1 minus b, that is 723 minus 14.2 will give you 708.8 counts. That is the correct number of counts in y, and uncertainty in y will be root the number of total number of counts, now addition of back also. So it will be sigma n1, that is 26.9 counts. So we now get it what is error in it. Y1 original value is 708 and error is 26.9. Okay, so it is not in this page, it's just randomly arranged here. So if you want to find the relative uncertainty in y1, that will be sigma y by y. Sigma y is 26.9 and y is 708. It will give you 3.8%. For second interval, as it was given, okay, the correct number of events in y2 is n2 minus b, just like in the first. 19 minus 14.2, that will give you 4.8 counts. Okay, uncertainty will be root of the total number of count, that is 4.2 root 19. Now y2 will be sigma y by y, just same as the for the first. Okay, now we will move that the middle page. Weighted sums and differences. If function is given like y equal to ax1 plus bx2, then you see that del y by x1 will be a, del y by x2 will be b, and we obtain sigma y square will be same error propagation formula, use that, and we get the result that sigma y square equal to a square sigma x1 square plus b square sigma x2 square. Okay, so if you get somewhere this type of function and you want to find the sigma y and a or b are given, so just square them and multiply their respective sigmas. Okay, so there is this question, it is asked in GRF 2017. The experimentally measured values of variables x and y are this and this respectively. What is the error in the calculated value of z from the measurements? So z is given 3y minus 2x. So a and b are 3 and minus 2. So just square them, 3 and 9, 4, and sigma y square, sigma x square. Use the formula. And you will get sigma z equal to 0.12. We already discussed this page. Let's move on. Suppose that in the last example, the example was that where background checks was given, background counts. The background counts B were not average over a long time. So actual the true value of background counts came when you take observation for a long time. But now in this question, he's or whether whoever it is, they are saying that the counts B were not average over a long time. It's just for a small time, but were simply measured for 15 seconds to give B equal to 14 with standard deviation root 14. Obviously that will be sigma in b, sigma b will be root 14 according to the Poisson's. Then evaluate the uncertainty in y1 and y2. Now what will be the uncertainty? Because now we see that b is now time dependent. When we take the b for a long time, then it will be an average true value. Now in the starting 15 seconds we measure that b came to be 14. Now b is in time dependent, and now we have to add the errors in b also in the errors of y1 and y2, because now there is error in b, that is root 14, and that is by 3.7. When b is not average over large time, the its measurement becomes time dependent. So y1 is n1 plus minus b. Now first it was n1 plus n1 minus b in the first case, but now in this question we will see the n1 equal to, sorry, y1 equal to n1 plus minus b. So sigma y1 square will be sigma n1 square plus sigma b square because their respective coordinates are 1 1. Now sigma n1 square will be n because sigma n1 is root n and sigma will be root b. So it's just n plus b. From here we can get what y1 equal to 723 minus 14 plus minus root this, so we'll get 709 plus minus 27.1 counts. Now from here you can calculate the relative error and all. For the second interval, the same procedure we follow. It is now 19 minus 14 plus minus root 19 plus 14 will give you 5.7, 5 plus minus 5.7. Okay, and you can calculate the relative error or relative uncertainty. Now, multiplication and divisions. Suppose y is the weighted product of x1 and x2. Weighted product may come into play when there is some integer is multiplied with the variables. So y is weighted product of x1 and x2. That is a times x1 x2. That's how we call it weighted product. So del y by x1 will give ax2, del y by x2 will give ax1, and variance in y will be sigma y square. Just same formula, the error propagation formula. Now in here we will divide it by ax2 a square x2 square x1 square. Then we will get this, we will get this, and from here sigma y will be this, just same. It means this a is not affecting anything. From here also in the division case we see that y equal to ax1 divided by x2, then sigma y square equal to this, just same. We already proved that. Now there is this example. The area of triangle given is half the product, we know base and height. If the base and height have values b and h are given, the area is this. Find uncertainty in A, so you can calculate that with the formula. There is this product, sigma b square by b square, put A, put sigma b h, sigma h, and find the answer. Now that in the last lecture I told you that we will discuss powers later, let's discuss the power. When y is obtained by raising the variable x1 to a power, that is y equal to ax1 by ax1 raised to power b. Then del y by x1 will give in a b x1 b minus 1, that is by over x1. Now relative error in y from the error propagation formula is this. From here we will get this result. From here sigma y square can be written this, and sigma y by y relative error will be b by x1 sigma x1. Now for the b equal to plus 1, we see that sigma y by y equal to del x by x. Okay, it's not depending on b, it's just depending on what's the value of b. Okay, so if it is b equal to 1, then sigma y by y equal to sigma x1 by x1, and if b equal to minus 1, then it will be minus of sigma x1 by x1, the relative error. So what's the negative sign here showing? It means a positive error. Negative sign indicates that in division a positive error in x1 will produce a corresponding negative error in y. Okay, it's just simple. Let's move. The area of a circle, maybe brightness is down, let me check. The area of a circle is proportional to square of radius, we know that. What is the uncertainty in a? So a is pi r square, we have to find the uncertainty in a, then sigma a by a, just follow the rule, that is 2 sigma r by r. From here we know that this power came into the front, and it is given from this formula actually, that sigma y by y equal to b sigma x1 by x. If power is b, then it will be 2 del r by r, and sigma a equal to 2a. Now put the a and find the answer. For a pendulum, T is given, G is given, L and T are measured as this. Obtain the value of G and uncertainty in it. Now just use this formula and find del L by L plus 2 del T by T, and it's half. Put the original values, you will get the answer. Easy. Now this is a random page. We'll see it. First, this page is, we have to see. To determine the quantity, this a student measure x and y as follows. What is the answer for q uncertainty in pq? So we have to find the uncertainty in Q. So first del Q by del X follow the same. Sigma y is Q square will be this, and we know the value of x, y, and sigma x, sigma y from the given question. Put the values, then find the sigma q will be 0.9, and original value we know that. Now there is this question, x and y are given, q is equal to this. What will the your answer in uncertainty? Follow the same procedure, okay, and then this page come into play. This is the page, and just same procedure, dictate. And this is the last question in an experiment. Conservation of angular momentum. A student needs to find the angular momentum L of uniform disk of mass m and radius r as it rotates with an angular velocity omega. C makes the following measurement. So m is given, r is given, omega is given. We know the angular momentum is mvr, and it can also be written as half m r square omega. Calculate L as L equal to this. What is for answer for L in uncertainty? So we have to find uncertainty in L, then that will be sigma L by L equal to sigma M by M, 2 into sigma R by R, sigma plus sigma omega by omega. Okay, so these all values are given, I think. These are all given to you. You have to just substitute them in here, and you have to find the value of sigma L. This will be your answer. So that's it. Tomorrow we'll discuss something new. We'll see that. Okay, till then, take care. Thank you.